welcome, James. This session is very much going to be Q&A based. Okay, there's not going to be a presentation. You have direct access to one of the greatest minds that created Java. So do think about questions. If anyone has any questions now, put their hands up. I'm going to ask a couple of questions to get started. I'll ask one question, then I'll jump straight to you at the back. So my first question then, Java obviously over 20 years old now. As your brainchild over 20 years ago, how has Java today lived up to your imagination, your vision 20 years ago?
That's a crazy question because, you know, there's just no way that 25 years ago, you know, I thought anything like this would be happening. And, you know, when Java started 25 years ago, you know, it was just me, right? And now there's a cast of thousands. And if you look at the crew that's working on developing Java right now, it's a lot of really talented people. And, you know, they've done a lot of really cool work. And, you know, I every now and then I talk to Brian Getz about how value classes are doing. And it's like, okay, Brian, so now you're on your 7th PhD thesis. You know, and, you know, it's been amazing.
So 25 years ago, it was more of an idea than just something that you thought might be useful rather than a language which you saw is actually going to change the way developers think about their platform and how they work?
Yeah, I mean, 25 years ago, what we were doing was going around and talking to people who built cell phones and elevators and locomotives and VCRs and televisions. And they all had software in them, and trying to find out what their issues were, and then because we were, you know, really convinced that the whole, you know, escape from the data center was happening for real, and the computer industry wasn't really paying attention. And the you know, as soon as you get into something that's not just, you know, data centers doing, you know, ATM machines and paychecks, that it gets to be a very different beast.
Okay, so I'm going to take some questions from the audience now. There was one at the back. If anyone else has any questions, do raise your hand so I can check you.
You mentioned earlier in your keynote that Java was very good for sort of AI, or can be very good for AI. I just wondered if you could expound a little more on that, by what you meant by that.
What I meant by that is more, I mean, in some sense it was a pretty simplistic comment, because if you look at a lot of the languages that are commonly associated with AI, like Lisp, the thing that really makes them work for AI is garbage collection. And you know, when you're doing AI kind of things, you end up building large complex data structures that are somewhat unpredictable. And you know, managing the storage and reclamation of those as you do the analysis of the situation can get really difficult. And if you're trying to do that kind of thing in C, it gets really difficult. And in the, you know, languages that have like reference count garbage collectors, they're pretty much a recipe for disaster, because you are going to get rings and you are going to get escapes. So it's you know, in my case, you know, I mean, probably the most interesting code I've ever written in my life is the code that does collision avoidance. You know, and it has to maintain a you know, a fairly interesting model of the situation around it, you know, because there are always, you know, multiple possible colliders. You know, you've got a mission you're trying to accomplish and goals to get to, and the goals may be vaguely defined, and you have to sort out, you know, all the different goals and all the different things that impact those goals, and then come up with, okay, I'm going to go in that direction right now. And yeah, I mean, really, you know, the collision avoidance is literally like 40 lines of code that took me months to write. but it was a lot of fun and a lot of simulation. But you know, that sort of thing comes out pretty easily.
Hi. When you initially designed Java and the API specifications, you thought long and hard about it. You put in Unicode when Unicode wasn't around a lot. That was very far.
Yeah, I got a lot of hate mail about Unicode. And then, of course, now that Unicode is 32 bits, it's like, oh, geez. Maybe it should have been UTF-8 under the sheets, but...
But one of the aspects was a GUI aspect, and it just seems like the whole Java community's forsaken the GUI, and the portability and applets have been dropped. You can't really draw anything on a web interface, and you can't access iOS or anything like that. Why have they given up on the GUI side? Can you shed light on that?
Personally, I think the people making those calls are complete fucking idiots. But, you know, that's, what can I say? People have gotten very religious about, building UIs on the web, and they think that you can do anything with the web. And you can do a lot with the web, but there are a lot of things you just can't do. I was really encouraged early on with Oracle's, support of JavaFX. And then they did this complete abandonware pivot off of JavaFX onto this jet thing that makes no sense at all to me. When technical decisions are made by, management at the top, when all of the engineers working for them disagree with them, you just gotta wonder. But that's where the community has really been nice, right? The JavaFX community has been somewhat driven underground, but they're remarkably strong. Where I am, we're doing a lot of JavaFX development. It works great. You made the comment about iOS, and the problem with iOS was not at all technical. It was entirely a decision that Apple made in their terms of service. If you read the Apple terms of service, you can't do most of the compilation tricks that the Java VM does, or that the Chrome JavaScript compiler does. So that when
there are projects in C# that they ditch the VM and they compile to Objective-C, and it's sort of like a transpiler, but it is possible.
Yeah, and there are like half a dozen projects that do that with Java, and the Oracle guys kind of at the last moment stuffed in an ahead of time compiler for JDK 9, and that is pretty much entirely motivated by the iOS issue and their license terms of service. You lose almost all dynamic linking, or at least dynamic linking with any kind of performance. So it gets kind of tough. There are a number of other folks that do it. There's a company called Gluon. I think they're in Belgium. They have a really nice little system that packages Java apps for iOS and Android. But it's sort of a difficult world when it's all sort of being beaten up by the web religion.
You touched on community earlier. How important do you think communities like the LJC, like other user groups, are to Java, and what kind of impact do they have?
The impact of the community has been huge, particularly under Oracle. I mean, it was a big deal for us at Sun. for me, one of the big deals with going out and visiting customers and doing, community events was always that it was hard to know what to do, right? It was hard to know what people actually needed to solve their real problems, as opposed to having, some out-of-touch manager sitting on a 20th story office going, I think I'll do that, and then having directing the marketeers to sell that. And there have been a bunch of spectacular examples lately of the community really making a difference. So the rather dramatic outcry over Java EE, where Oracle was trying to take it private, or the outcry over NetBeans, which given how much sweat and blood I've put into NetBeans over the years, that was just wonderful. And the core Java platform, which Oracle is, that's the piece that Oracle is doing the best job of supporting, if only because they figured out that they would absolutely be dead without it. Getting feedback from the community is a really, really big deal for them. And it's sort of two pieces, right? Part of it is the technical input on what's good and what's bad, but the most important thing ends up being essentially the economic impact on because almost all the people in the developer communities have fairly influential positions at their employers, and they have a pretty significant say on where the money gets spent. And tragically, that's really the only metric that Oracle pays attention to. None of at Sun we used to have like a zillion metrics on customer satisfaction, and I remember this one rather annoying meeting where a certain unnamed senior Oracle executive said, well, we can get rid of all of that. None of that matters. The only metric Oracle cares about is whether or not they sign the check. And it's tragically true. So you all have wallets, and you basically buy votes. That's kind of the way it works with them. So make sure that if your Oracle salesman shows up, twist their arm until they get dislocated.
What do you think about the way that the direction that Java is heading in at the moment, with respect to the modularization and also some of the newer stuff that they're doing to generics?
I'm basically really happy with the way that the core Java evolution is happening. A lot of it has been, some really hard problems. So for instance, like in JDK 7, the inclusion of lambdas. And it's like, well, why weren't lambdas in there before? They seem like so obvious. Well, yeah, lambdas have been obvious for a really, really long time. But if you try to do lambdas with no apologies about performance, then it becomes really difficult. Lots of systems have had lambdas, and you talk to authorities and programming languages, and it just turns into a big food fight because this style is better than that style is better than the other style, and I don't know how many SIGPlan conferences I've been to where they get these religious debates about how to do lambdas, and convergence has really been hard. And I can't actually say that there has been any real convergence, but in figuring out how to do lambdas so that, for instance, if you use, for each iterators over collections, it is at least as fast as using a regular for loop or sort of hand coding it. If you look at what some of the folks have been doing, with the kind of inlining tricks that the optimizers do, it's pretty freaking amazing. Because all the hard parts are not in the specification of what the semantics of things like lambdas should be, but how to make it so that it's clean and accurate. And so like in JDK 10, I guess it's 10, the one that has been, you know, at the top of my wish list forever is value classes. And I remember Brian Getz coming to me like 2 years ago saying, okay, we're really going to do value classes this time. He said, how hard do you think it had been? And I'd spent a lot of time on value classes, and I said, well, half a dozen PhD theses. And he said to me, oh, no, it's only a couple of PhD theses. and not too many months ago, he came back to me and he said, well, James, you were the optimist. Because I think they're going to end up at somewhere near a dozen, you know, things that should have been somebody's PhD thesis topic.
Would you position value types or value classes above anything that's in JDK 9 now? Jigsaw?
Yeah, I guess I would, if only because as an intellectually difficult thing to do well, it's been a shimmery, scary thing for a really long time. You know, I mean, it's just intellectually hard. And the intellectual hard part is not specifying what the semantics of value classes should be, but how you do the underlying performance optimizations so that they're really fast, right? So that if you do something like you specify, like, you know, 2-dimensional points or 3-dimensional points or complex numbers or something like that, that, you know, there's no storage allocated. They're never written to the stack. They're only kept in registers. You know, they never really exist other than in some AST somewhere, and that all the you know the calculations just fly. Because one of the things that's always been a big deal for me for Java is being as close to the kind of ease of use and intellectual integrity of a lot of the sort of fancy high-level languages, but without or with as few apologies about performance as possible. So like in JDK 9, the big thing is modules. And we've taken many runs at modules. And the problem with modules isn't modules so much, but it's how do you take advantage of them? How do you make them clean? How do you make them simple? And modules have been on the list for like the last 5 or 6 JDKs, but they've always like fallen off because really exploiting them has turned out to be hard. And so at by the time JDK 9 came around, it's like, everybody said, yes, we have to do this. If only because Corba must die.
Where did OSGI go wrong?
Huh?
Where did OSGI go wrong?
Well, it was the Open Systems Gateway Initiative, right? It was this whole thing designed to do something else, and there's this like little slice of it that really got used, and for me, the OSGI was just too complicated for what it does. But that's not an argument to have with me. I always just like run screaming when that argument shows up, because like people often complain about how big and clunky some of the Java libraries have become, and then they say, oh, but why didn't you just import all of OSGI? Right, which would have been like humongous and clunky. So it's like, please make up your mind. More questions?
I was just wondering what your thoughts on the future of Java EE and the implication that containerization technologies such as Docker will have on it.
Well, I've been having a lot of fun with Docker. I'm hoping that eventually EE can start taking advantage of things like modularization and containerization. One of the biggest issues that Java EE has is that it's a big thing. You know, if you look at the full up Java EE spec, it's got everything in it, and you know, you might think that, you know, it really should have been done as like a series of independent APIs. And I think any sensible person would probably have done it that way, except that, you know, the welding together of all of these pieces became you know, kind of a marketing thing, right? It was like completely out of the hands of the engineers. And if you look at how it was actually built, it's a bunch of independent APIs. But from a marketing point of view, they're kind of welded together. And I'd hope that it, you know, that eventually that can be, you know, better modularized. So there's less linkage between them. And there really, you know, in actual fact, isn't a lot. But just as a matter of packaging, it's gotten kind of out of control. Right, so that you know, now that there's like two versions of Java EE, it's like the web profile and all the exotic stuff that only like 5% of the universe uses. Except that I think that like 90% of the universe uses like one thing out of the full profile. At least that's been my experience, right? Is that I use almost nothing out of the full profile, but there's always something. Yeah. So he just reiterated my experience, right? I mean, that's been kind of the overall tragedy of the Java APIs is that, you know, you try to pick something that isn't used by many people, and it's only used by like 1 or 2% of the applications out there. And you say, well, gee, only 1% of the people, like only 1% of like developers are using it, right? But okay, so you got like, you know, 10 million developers, whatever it is. You know, if you get rid of something that 1% use, you know, you got 100,000 really angry developers out there. And so lots of exotic stuff just stays there. But the only thing that there's sort of wide agreement that you can get rid of is Corba. And things kind of trail off after that. So next question.
Yeah, so we were talking about language features. So what do you think about Scala and its approach on extending the language and, you know, other languages built on top of the JVM in general?
I like them a lot. I mean, I think the different languages, you know, exploring things. For me, almost all of the real magic of Java is in the VM. There are a lot of, you know, nice things about Java, the language, and you know, all these languages come at things from sort of different ways. You know, and I've done some projects in Scala and been pretty happy with it. And actually, in the last project that I did in Scala, my big issue with it is that it really wants to allocate lots of objects, and so if you know, it's sort of heap churn heavy. But other than that, it felt really good. And I particularly like Closure just because the sort of immutable object style has some really positive impacts. I mean, it can be really hard to write in that style. And if you try to do sort of immutable only objects in Java, you can do it, right, where you declare classes where every field is final. You can get some really cool things out of that, you know, things around threading. I did one where the undo history was based on the fact that all objects were immutable. And so going back one level of undo was just like switching a pointer. And you did all mutating by rewriting. And it can work really, really, but a lot of these end up having styles that people find hard, right? So the everything must be immutable style, I think is great. A lot of people try it and go, what? I don't know how to think that way. For me, the most depressing thing about Scala is it's sort of built as a functional programming language, and you can write really nice functional programs in Scala, but because it's sort of got this, well, it can also be procedural too. If you sort of randomly select Scala programs by grepping around on GitHub, you find that most people end up using Scala as Java with abbreviated syntax, and don't really write functional code nearly as much as they could. Next question.
So today, when you sit down, you do some work, what's your environment like? Do you work from home? Do you work from a place? What tools do you use?
So let's see. I use NetBeans. On our cloud side servers, we had been all Glassfish until clusterfucked. And now we mostly use JBoss or Wildfly, and that was partly motivated also by the fact that we have a bunch of customers that have standardized on JBoss, and they want to be able to run our software in their data centers. So JBoss kind of works well with a lot of them. On the robot itself, it's the robot itself. Its control system is a big bag of Java code. We use embedded Jetty for some of the control stuff. We use there are a bunch of libraries that we use. Like there's a library that I love called JTS. I don't know if anybody here has ever used JTS. It's the Java topology suite. If you want to take a detailed map of Europe and Asia and intersect it with the outline of a ship, where the map of Europe and Asia has like millions and millions of lines. Works great. It's a really nice package if you're doing that kind of stuff. An awful lot of the maps you've ever seen are like JTS underneath them. Let's see, we use Git for our source control, although we mostly don't use GitHub. There's a thing called GitBlit, which is kind of if you want to run your own version of GitHub internally. And we do that mostly because that makes it easier to tie into other tools. We use Jira for bug tracking. We use Garrett for managing check-ins and doing code reviews. Yeah, for debugging, I try to run things on my laptop, but tragically, I think the debugging tool I use most often is Println. It is sort of the tool of choice for too many desperate people. What else? Oh, I should stop. Next question.
Yeah, well, first, I'm also on the print line side of things when it comes to debugging, so I think that's still very widespread. My question, though, is about, do you have any specific thoughts about generics, and particularly extending them and getting rid of erasures? My perception is that this has been a prolonged process by the, whatever I should call it, transition from Sun to Oracle. But is there any chance this process might be completed And as one sort of a teaser, I think this might unlock a whole lot of wealth for things like persistence, yeah, object relational mapping, or whichever you want to call it, because at this point, erasers put a limit to that.
Yeah. Long, nerdy debate. I'm really the wrong person to have that debate with. And fundamentally, I agree that getting rid of erasures and doing it and sort of cleaning that up would be a really, really good thing. When we first did generics, the sort of overriding thing was to be able to do generics while maintaining, sort of a smooth transition from the past, and so how to do. And actually, several people have done some really nice proof of concepts of how to do erasures properly, and it's been on the list for a long time, but it's been it's on the important but not quite important enough list. So if I had to rank it against like lambdas and value classes. Value classes would absolutely make a big difference to me today. But, write letters to Brian Getz, because right now he's kind of the lord of that. But I'm sure that what he would say is, yes, we'll get there. And if somebody in the community was to do a really bang-out job of implementing it, people would be really happy. Next question.
I usually used to have one doubt, has Java really lost its focus? Initially, we were thinking about machines. Java is written for the machines and things like that. I remember there used to be a project called Genie, and then we moved all our focus to JEE and totally forgot about what Java was initially planned for. Are we coming back to the circle of Internet of Things? And what would have been your vision in those days of Internet of Things?
The question of focus is always a hard one. If you've got a task to do, you can focus on it and just get it done. When you've got a tool that people find useful for this and useful for that, and useful for the other thing, it's hard to maintain focus, because you find that Java is not something that Sun or Oracle ever steered in any particular direction. Java has always been something that was taken in strange places by the developer community. And a lot of that has been just like amazing to watch. The apps that people have written are just like crazy. But I personally just thought that Genie was the coolest thing ever. But it's sort of it was one of these things that got caught up in a marketing war. One of the problems with Genie is that it used some of the networking aspects of Java that were really hard to replicate in other languages. So in particular, the way that you could do a remote method call, in RMI has this really great feature where you can have a remote object, you do a remote method call, or you send an object to a remote machine and say, apply this method on it, but the object that you just sent over is an object for which there is no code on that machine. And then the machine will reach back and say, give me the code for that, right? So people would do things like, a really interesting, cheap batch execution environment where, you would have the main program would essentially say, pull something out of the queue, and it's a queue of runnable objects, and then you just run the runnable object. And then, some remote guy sticks a runnable object into the remote guy's queue, and then the code just kind of follows it. Really, really cool. You can do really powerful things with that, and Genie really exploited that. But that doesn't port to any other programming languages anywhere, right? And so that got, it had this interoperability problem, and then outfits like Microsoft sort of, start these like gigantic marketing campaigns, and it turns into, when API directions are they turn into massive food fights in the commercial press. It's a little crazy, right? So many of these things that like SOA and XML, they became overly politicized, and whatever, right? Next.
My question is about the latest shift of technologies that is happening towards these JavaScript-based frameworks, and people are actually considering them as main tools for their web application development. So, what's your take on that? And have you had any experience with them? And if yes,
So which frameworks?
the JavaScript-based frameworks, there is a shift that is happening now. Working on like Node.js or Express or these sort of things. People are shifting away to these ones. So
Well, you can do a lot in JavaScript. There's a lot you can't do in JavaScript. One of the things that just annoys me to no end about JavaScript is that, there exists a standard, but it's only kind of, it's not very well adhered to. And even, within one manufacturer's product, if you try to make a piece of JavaScript run on every version of Internet Explorer, you're pretty much doomed. And that actually ends up being one of the driving forces behind a lot of the frameworks, because the frameworks hide a lot of the rubbish that you get from version to version, and it's hard to tell these days what is a framework and what isn't. So like probably the thing that's used the most is jQuery. And then there are a bunch of things that call themselves new frameworks, but they're just jQuery with window dressing. There are just so freaking many JavaScript frameworks. It is completely impossible to have any kind of sort of well-informed technical opinion, right? It sort of boils down to whatever has burned you the least, and so I tend to just use jQuery and 2 or 3 of the packages based on jQuery, and I stay away from the fancy packages. A lot of the JavaScript on the server side is driven by people who don't know how to do anything other than JavaScript, so that saves them energy. And the problem with things like Node.js, it's really good if you're just doing simple things because it's got this like non-threaded, sort of JavaScript-ish kind of model where you do simple things and you get simple answers. But as soon as you cross over into more complex things to be done by the server, Node.js quickly falls apart because you end up with these like state machine styles and things that JavaScript doesn't do very well. And for me, when I'm running website stuff, I mostly end up way out there in the complex land, just starting, right? I'm never trying to populated drop-down list with, a list of, nearby stores. I'm always trying to do something more complicated than that.
This is a bit of a more personal question, but as they call you the father of Java, having created something 25 years ago that is now taught in thousands of universities worldwide, used in millions of devices around the world, how does that make you feel on a personal level, as this is something that you wrote and how widely it's used and how widely it's taught?
Personally, it's kind of a weird feeling. Most places I can wander around and people ignore me. I cannot go on vacation to India, ever. It's crazy. And San Francisco is mostly okay because people are polite. The really hard problem is, when you have kids and, you are responsible for the APCS course, right? And, they start out in APCS and all the other kids assume that you are like the best person ever because it's your dad, right? And it's like, no, running away, screaming. Neither of my kids want to have anything to do with CS entirely because of me, even though I think they'd both be pretty good at it if they could just get over it. But, it's also something that from a technical work experience point of view, I kind of OD'd on it like a decade ago. And I'm happy to be doing something else now. So now I'm a user instead of a producer, which is a really nice feeling too. It's like, oh yeah, that actually made sense. And so that's been good. Next question.
Hi. Some months ago, there was this lawsuit between Google and Oracle, which seemed to be very damaging on Java, I would have thought. But is Java safe within Oracle?
Yeah, I mean, other than that stupid court case, it's extremely safe. If only because like almost all of the Google of the Oracle technologies are based on it, and they know it, and it would kill them. That court case is just crazy, and it's sort of an outgrowth of the fact that Oracle's a coin-operated machine, and a bunch of lawyers are convinced that they can get a gigantic settlement payout, and it's like, yeah, but it's stupid. It's harming the rest of the business, but. Yeah, but it's just like these lawyers, they kind of go, but I'm not responsible for that line item. I've got my own line item. And it's like, it's just math, guys. But it's always, line item local, business line item local. And it's like, it's just crazy. I mean, makes zero sense. Other questions?
There's some features in Java, such as the class loader, which I think are way ahead of their time. You couldn't possibly have conceived of all the usage of things like the class loader. Is there anything that you wrote very early on that you think is sort of understated?
Well, I actually think that class loaders are still understated. I mean, the things you can do with class loaders are just like, just crazy. The one that's kind of in there is security managers. There are a bunch of things you can do with security managers that I think people aren't doing yet. And there are a bunch of things in class loaders I wish I could, like I've got this one bag of code right now that has this problem that I really, really, really want to be able to reach into a class loader and find all the jar file artifacts, all the class file artifacts behind it, which you can't because people are often playing crazy games with class loaders, so there really isn't a class file behind them. but nonetheless, sigh, but ones that are underappreciated. Security managers are kind of at the top of my list there, but I wish more people were playing with JavaFX. That is a really, really cool library, and I've been having a lot of fun with it. And it's sort of, you know, has political problems, but very cool. Next question.
Building on that, you have mentioned things that you would like to see in Java in the future as soon as possible, like value classes. But if we could look at things to remove or to break, even breaking backwards compatibility, what is the thing that you would like the most to change or to remove, and because it would have the highest impact in the future of the language? Thank you.
I don't know about highest impact, but on my sort of annoying list of why did I do that was things like making switch statements be in the same style as C. I mean, that was just dumb. I mean, it was a good idea in the sense that it sort of attracted a lot of developers, but it could have been done differently. I still really miss... has anybody here ever used Simula? Yeah, one person. Okay. So I used to do a lot of work in Simula, and I loved the Simula inspect statement, which was a cross between a switch statement and instance of, and you could do some really interesting things with it. I liked it a lot. You know, I missed the with statement from Pascal. You know, it's hard to know. I mean, you can do some tricky things with the C-style switch statement, and I have to admit to being one of the worst offenders. Yeah, you know, and then there's the sort of language things like, or sort of library things like AWT event handlers. What were we thinking? Next.
A lot of languages have optional try-catches. What are your thoughts now on having forced try-catches?
So try-catches were like a really difficult debate. I did the first implementation of try-catch, and they were not forced. They were completely optional. Because I was really nervous that there were a whole lot of classes that, or a whole lot of exceptions that were so ubiquitous that you would have to have try-catch statements everywhere. You know, if you tried to do things like null pointer exception that way. But this was a point where Bill Joy was like just jumping up and down, like steamed up about, and literally one night, he and another engineer came in. They implemented the type checking on try-catch and went through the agonizing thing of breaking the exceptions down into the checked and unchecked categories, which when I came in that morning kind of made me grumpy. I was really pissed off, and then it's like, you know, this actually works really well, because you know, and you know, when I said I didn't like it, it was more kind of an ambivalence, because you know, one of the things that I'd always been really cranky about C with is that, you know, all kinds of things were returning error codes, right? Like you know, like the open system call, you know, returns an error code, and you have to check for those error codes everywhere. And one of the biggest sources of reliability problems in C code was just that people wouldn't check error codes. And so when you make exceptions optional, people go, oh, I don't have to do that, right? And then, the open system call fails and, works great on my laptop because, /home/user/jag/foobar is there and the software works. What do you mean it doesn't work on your machine? You must be doing something wrong. And by forcing people to pay attention to exceptions, and then it turns into this delicate judgment call about what things should be checked with exceptions and what shouldn't be. But I think on whole it has worked out well.
Yeah, this is about JVM. You alluded about your near to the JVM earlier, and you like JVM languages, etc. So as a developer, we are more familiar with the Java and syntax and the business, the cutting the code, etc. But we are not sure what JVM is really all about and what it really wants. And when we are actually attaching to the JVM, the various tools say that actual tool itself is lying, and what JVM is really doing underlying, nobody knows. So the visibility to JVM is not there to us. So in your point of view, what a developer should know or must know about JVM, and what annoys you from developer point of view? What are the things they are not considering JVM point of view, so that JVM is happy what the developer has written and it is well written and well performant code as well?
So one of the design goals of the JVM is that you shouldn't have to pay any attention to it at all. That the things it does for you are pretty much transparent. So, for example, if you've got a big data center, you didn't buy all the machines in it all at the same time. So they've all got slightly different chips on them. Even if they're all Intel x86s and they're all running, Ubuntu 16.04, they're probably slightly different Intel chips. And the JVM ends up optimizing your code for exactly the chip that's on the box that the code is running on. And so you don't have to worry about, compiling 12 versions of your optimized program to run on every flavor of Intel chip that happens to be in your data center, and then going through the deployment nightmare of making sure that the right versions are run on the right chips. You just say, please run it for me, and the JVM does the right thing. Same thing with things like garbage collection. In earlier versions of Java, you used to have to do all kinds of tuning of JVM parameters. And these days, that's almost never makes any sense at all. For some people, it makes a big difference, but there might be like 2 people in this room for whom that is actually important. And for the rest of you, just trust that it's doing the right thing.
Why no tail recursion optimization? And is there some reason why it's difficult, or do you think it will happen at some point?
Tail recursion optimization, the JVMs can do tail recursion optimization. They might. It's just, it's not specified in the language that the optimizer must do tail recursion elimination. And a lot of that has to do with interactions with things like debugging. And the definition of stack traces. What happens when something goes wrong and you get a stack trace that doesn't have everything in it. sometimes VMs do tail recursion elimination, or the equivalent of it. Complete inlining of stack frames happens. But really the hard problem with tail recursion elimination is not, because the VM is free to do it, so long as it doesn't muck up with semantics, right? So if debugging is turned off and yada yada yada, the VMs can do it. But if you try to write a language specification that says, under these circumstances, tail recursion elimination must happen, which is what some of the Lisp-like languages try to do, they end up with really contorted specs that tend to not make any sense, and they're essentially always wrong because they were right, in the implementation of 5 versions ago, but now they're wrong. So it's a transparent, non-mandated thing, completely possible, and debugging is the usual thorn. Next question.
Hi, this is not very much about Java, but then I want to know what you think about the future of computing as you see it. We have AI coming, Internet of Things, and also quantum computing, which is in the infant stages. And we have this revolutionary memory chip coming out, the 3D cross-point technology. So where do you see the future of computing is going to?
If I could see what the future of computing technology was going to be, I would be a really wealthy person. And I guess for me, the thing that's been, I've been in this business for a really long time. I actually earned these gray hairs the hard way. It's sort of been like, every year it's like, computing, it's just exploding. It has to slow down because there can't be anything else. And it's been in a constant state of explosion, for too many decades. I've actually been been getting a paycheck as a software engineer for 47 years. So that's a little frightening. And there's just no detectable slowdown. And I think it's just, damn. The way you think about things changes every day.
And one last question about, given that you've been father of Java for 20, 25 years, and you've created probably the biggest programming language with the biggest ecosystem that the world has seen. What do you do after that? What excites you about your job? Where do you go from that? And why did you pick liquid robotics as your next venture?
I get to go snorkeling with robots in the ocean. I've never had a software job where one of the requirements was must be able to swim and snorkel. And the fact that we've got an engineering site on the big island of Hawaii, and I did a lot of the vehicle dynamics, the rudder control and that kind of stuff. So I spent hours and hours and hours swimming with robots, and damn, what could get better?
I was just wondering, you mentioned in your keynote speech this morning about write once, run anywhere, whether you had any horror stories, particularly maybe HP Nonstop or IBM mainframe?
Horror stories. I guess my biggest horror story with the whole write once, run anywhere thing was the early days of cell phones. Because we worked really hard on making it such that your Java program could go from one place to another, and then you discover that the screens on all the cell phones are all so different that all the game manufacturers reauthor every piece of artwork for every screen, for every model of every cell phone, because the color calibration and pixel density of every screen was always different. And so it's like, well, you try to do the right thing, but you can't actually, we didn't actually write a spec for color calibration in the image, in the graphics library. And so every phone manufacturer did slightly different things, and then every person writing games was doing slightly different things. And these days, the only reason it's kind of okay, like in the Android world, is that there's only like 2 companies that make screens, so they're all reasonably consistent, and the sRGB model has kind of taken over the universe. So, but in the early days of cell phones, that was really annoying. So.
Okay, that's actually the last question, all the time we had for this stage. So please join me in giving a big round of applause and saying thank you to James Gosling.
Thank you. Thanks for inviting me.